So before we get started, I want to just talk about generally about weather data and the way that weather data is constructed and kind of the logic behind what we were looking at yesterday. So let me share my screen. So So one of the focus areas of this workshop, it goes back to interest in not only information visualization, but specifically environmental data visualization. And one of the issues that was brought up yesterday was the fact that when we were looking at the REST API example and the fact that although there was a connection to real-time information, however, the comment was that, well, it is not changing often enough. So we want to talk about that a little bit today. When it comes to environmental data, there's still a lot of large gaps in the information available, but also whether it's real time or whether it's static and working with an archive, there's a lot of issues that I think it would be important to bring up. And this is not so much, let's say, the visualization workflow end, but it's more about the lack of availability of data. So maybe some of you are already, let's say, familiar with platforms like Ladybug and Honeybee or any other environmental visualization platform. And what you realize along the way is that no matter what the platform is, often these are relying on weather data that comes from sources like this. So let's say if you're looking at city of New York, when you are looking at your EPW weather data, you realize that, let's say if I'm working in Manhattan, but there are not that much information about Manhattan itself, but these are weather stations that are scattered all over New York. And what happens is that then, although let's say you're designing a tower, you're designing something very specific that could have wind parameters, solar parameters, you are working with generalized information. So you're working with a general a vector of movement, general sun pattern. And maybe that's okay up to a certain level, but if we really want to be able to make very local decisions about the architecture that we're creating, perhaps that's not a resolution that's enough. Alternatively, what you could do is you could collect your own data, right? But that's, again, this is a database issue. So here we were looking at how to collect location of trees in city of Yerevan, and that took weeks and weeks. So either you could go with the existing information that comes from simulation or weather data, which are low spatial resolution. You can do your own collection, but the problem is that if you have a couple of people that are going around, perhaps they're also missing temporal resolution because you cannot have the same people in the same location all the time, right? So this relationship between spatial resolution and temporal resolution is really important, and there is a discrepancy. So in the sense, when you are relying on using people for data collection, the visualization mode could perhaps start to change. But again, this disconnect between spatial and temporal is an important issue to bring up. So here with students, we were looking at how to collect CO2 data and tree data at the same time, because both of them were missing from the site. So it's an exciting process, but you end up most of your time focusing on creating the database versus the analysis itself. So this is a classification that is important to note anytime that we're talking about data and data visualization in general. And this classification, which you could see that there's these 4 terms that you're seeing being repeated and used in combination. So what is the relationship between local versus remote? The other one is the relationship between static and mobile, right? And then you have combination of the two. So for instance, what is an example of local static sensing? That could be the weather station. So the weather stations that yesterday we were looking at open weather and the information that was extracted from there. So if we look at this, we can look at weather data sensing. This could be a precise information, highly calibrated. This is costly. There's an expert community that makes this. In theory, it should have high temporal resolution, but it's going to have low spatial resolution, right? So this is going to be over city scale. Versus if you're looking at here, we're looking at relationship of the sensor to the object itself. If we're looking at other methods such as local mobile sensing, so locality is the relationship of the sensor to the object itself. So you're present in, let's say, for that specific site. If you're then relying on sensors that are attached to cars, attached to scooters, if this is some kind of a wearable, you're able to do the exact opposite of what you're getting from weather station. In this case, you have no temporal resolution because, again, you cannot clone yourself to be in the same place all the time, or not everybody can do the sensing all the time, exact same time, but you can potentially reach high spatial resolution. So the problem with weather stations is the fact that these are often placed on either private or governmental territory, right? Because they need to be monitored. You cannot get a permission to have a weather station of this sort that is, let's say, large scale. It requires also a lot of cost. So a weather station like this would be millions because each of these sensors are highly calibrated. So as you can imagine, you cannot afford to have these weather stations everywhere and all the time. Also, because they require specific site and they need to be, let's say, in a place where they have good reception, but also they're able to do sensing. These are usually placed in a location called idealized location. These idealized locations could be away from the city or quite isolated, right? So again, it's not a perfect condition because here I'm looking at Valley in LA. If I'm interested in knowing, let's say, what is the pollution that I'm sensing inside the valley, obviously there's going to be a gradient of difference between temperature and other readings here. So again, there's a discrepancy. So a lot of the work in last years in environmental sciences, there's been this very big disconnect. There's the camp that thinks that, yes, you could definitely go with this idea of local mobile sensing, and you can have volunteers and you can have students, you can have people contributing to the data. So there's been a lot of projects that have been doing this. So one of the most famous ones is a project called Purple Air, which is one of the most successful projects when it comes to environmental data collection. So Purple Air is a sensor that actually, I have a few of them here, but it's a sensor which is near $250 that you can buy and you can attach to your home. There's an indoor version and an outdoor version. If you look at the map over the years, this has gained a lot of popularity. And what's nice about it, you can go to this website and you could, take a look at what is the neighborhood information based on this. So for instance, at University of Southern California, around here, there's a couple of sensors that I've set up, and these are just collecting information, and anybody could go and, let's say, look at the information. Now, these again maybe lack in spatial resolution, but the promise is the fact that many people could start to contribute to this, right? And what is also quite unique about this sensor is the fact that for the first time, you have a pretty decent particulate matter 2.5 and particulate matter 10 sensor that you could use for information collection. Now, this this platform is also something that's used by the city, so this is definitely one thing to look out. They do have their own API. It's a little tricky to work with, But the promise of platform like this is the fact that you could, contribute to this information as much as possible. But the reality is that a lot of these projects fail. So one of the projects that is in similar vein is a project by a lab that NJ used to work with, Sensible City. So this is a project called Copenhagen Will Project. And this was one project that was trying to combine this idea of sensing with also mobility. So this was a quite important, let's say, step in urban sensing, because it embedded sensors in this back wheel that you could see. And it allowed you to not only track your speed, but also track some environmental parameters as well. So it was quite groundbreaking. So this would be an example of local mobile sensing, right? Similar to either you do this yourself, or if going back to, I'm gonna skip ahead, in City of London in 1950s, they were also looking at how to attach information with cars for the first time, and they were able to do this local mobile sensing. So I'm gonna move ahead and talk about one thing that we're trying to, in a sense, look at in a course like this and start to question. So currently, if you look at a lot of environmental data visualization applications, they're using, and these are, let's say, often open source, open access apps that allow you to, just by accessing location, understand, let's say, general weather or meteorologic information, such as air quality, but often weather. And pretty much all of these are listening to the nearest weather station. So the app knows your where you are and is trying to connect to the nearest weather station. Now, again, the problem with this is what we discussed in the beginning, right? There is just not that many weather stations. So again, you're lacking resolution. So this is something that I think it's important to note, because as much as real-time information is exciting, but if your initial data is not high resolution enough, then there is still discrepancy in the workflow. So one thing we want you to do today is to go to this to the Open Weather website and make an account. So so Open Weather is one of the open source places where you could get weather information, and that's what NJ's example yesterday was using. So if you go to openweathermap.org, openweathermap.org, if you, sorry, yeah, so openweathermap.org, and there is an option to sign up. So on the upper right corner, you would see an option to sign up. And if you fill out your information, so it's going to be your name, your location, pretty much like quite general sign up. And what you're going to be able to do with this is you can have your own API key that you can then use in the example, and begin to use the example more with your own key. So go to openweathermap.org, sign up, and with that, you'll be able to have your own API key to use in the example. All right, so we will come back to this, but if I'm gonna go to the map, so let's say I'm currently in Los Angeles, and if I look at the weather station, you can see that it's extremely scattered, right? So for instance, for entire downtown Los Angeles, there's one weather station. There's one for Santa Monica. So these are the keywords that you're ultimately using in the example to fetch the data. But again, you could see that this is a serious problem. In general, the city that has the most information is New York. New York, because it has a lot of governmental agency. And after Obama was elected with the Open Data Initiative, with the Open Data Initiative, there's the city has the most GIS data and ultimately data resolution in general. So if we hop all the way to New York, you'll see that, but when it comes to weather station, it's still very, very scattered. So for the entire island of Manhattan, we only have 2 weather stations that we can fetch data from. So that's one of the things we will do today. And for each weather station, if you click on it, usually, obviously, a platform like this is trying to make the information as coherent as possible. So general country, temperature, clouds. So this is percentage-wise. And so again, some cities are higher. But let's say the general information that you would get would be temperature, humidity, pressure, wind direction, etc. So this is a good website for accessing real-time data, but it's not the best website for looking at extracting weather data. One of the best websites for extracting weather data is a website that was generated in China a few years ago, which allowed to, in an underground way, kind of verify weather data reportings. So this website, which is called AQICN, so AQI, which is the air quality index, and CN for China, so AQICN.org, has been one of the most, I would say, robust ways for reporting data. And what this website is trying to do is actually anywhere that it's missing data types, it's trying its best to calculate, or it's trying to tap into multiple weather stations. But again, when it comes to New York, we still have the same, in this case, Manhattan, the same weather stations, but it's actually tapping into a couple of organizational weather stations. So there's a couple of university weather stations that it's also trying to tap into. So I would say that in terms of type of information it's reporting, it's slightly better than open weather, right? But again, like whether we're looking at open weather or whether we're looking at our AQICN, again, the lack of availability of spatial temporal data is the reality of where things are. So alternative to this is simulation. And with simulation, what one is trying to do is to try to interpolate the information. So it's trying to basically create a lot of averages by looking at this network of highs and lows, right? So we just wanted to kind of talk to you about the state of the art when it comes to existing weather stations. And what you're going to see is, let's say, this number 33, which is associated with this weather station. It's not exactly matching this index. So these are obviously, each website has its own way of sorting this, but ultimately the source of data is often the same one, right? So the AQICN has a couple more here, and I believe one at Columbia University or run by Columbia University. All right, so that was a kind of a general introduction to information visualization and kind of the problem of data itself. Thanks.